Hi and welcome to another instalment of our regular tips and tricks episodes. After a run of in-depth 30-minute tutorials, this time we're going to return to something a little more concise, as we share a time-saving graph snippet for extracting individual tiles or bricks from textures. In the Railclone 2.4 feature tour, we showed how the UVWXForm operator can be used with a random offset and step parameter to grab individual tiles from a texture. The problem here is that while you can enter offset values separately for both the U and the V offset values, there's only one step parameter that's used for both axes. This is great as long as the texture has an equal number of tiles, but if the number of tiles is different on each axis, then the textures won't align with the segments correctly. In this tutorial, we use multiple UVWXForm operators to separate the controls for the U and V axis. In addition, we'll automatically adjust the segment's UVWs so that they scale to fit an individual brick to save you from having to manually adjust the UVW coordinates on the source geometry. And then building on this example, we'll finish up with a more advanced example that calculates the offset required to extract textures from a running bond pattern automatically. This is useful for bricks, which are often found on texture sites in this format. As well as learning more about the UVWXForm operator, this tutorial will also provide a helpful introduction to exporting parameters and creating arithmetic relationships between properties. First, a bit of theory. Values in Railclone can be either cumulative or non-cumulative. Non-cumulative values are always overwritten by the node wired last in the chain, whereas cumulative values are additive, and the final outcome is the sum of the relevant values of all the nodes wired to the generator's input. For example, in this node tree there are two transform operators, wired one after the other. If you set a left padding value of 10 cm in transform operator 1 and a left padding value of 20 cm in transform operator 2, then the actual padding value used is 20 cm. The second value overwrites the first because padding values are non-cumulative. On the other hand, if you set an X fixed transform value of 10 cm in transform operator 1 and a value of 20 cm in transform operator 2, then the actual value used is 30 cm. The second and the first values are added together because the transform values are cumulative. This tutorial exploits the fact that the values contained in the UVWXForm operator are also cumulative, so we can use two or more UVWXForm operators to control the U and V offsets, step values, and much more separately. In the first example in this tutorial, we'll extract the tiles from this texture that's 4 tiles across by 13 high. However, rather than hard code these values, we'll make them editable from the parameters rollout so that other textures can be used without expecting the user to open the style editor and understand the graph. To do this, we export parameters and wire them to numeric nodes. Whenever a numeric node is added to the graph, an entry is created in the parameters rollout so that a value can be entered outside the style editor by the user. So let's try this. Open the start file from the downloads for this tutorial and select RC tiles from the scene. This is a simple Railclone object that creates some tiles with a 6mm padding on all sides. At the moment you'll notice that each tile is mapped with the entire texture. So first let's adjust the tiling so that each segment only displays the bottom left tile of the texture. To do this, we'll change the fixed tiling value. UV space is represented by a value from 0 to 1, so if we divide 1 by the number of divisions in the texture, 4 in this case, we'll get the fixed tiling value we need. To do this, create a new constant node and set the mode to float and then enter a value of 1.0. Next, create a numeric node. Change its name to the number of tiles on U and set the value to 4 from the parameters rollout in the modify panel. Finally, create an arithmetic node and set the mode to divide. Wire the constant node 1.0 to input 1 and the numeric node to input 2. This will give us the tiling value for the U axis. So to adjust that, add a new UVWXForm operator and name it UXForm. Wire this between the segments and the generator. Now right click on the new UVWXForm node and export fixed tile U and wire this to the arithmetic node. If we get in close and look at a single tile, we can see that only one texture should now appear on the U axis for each segment. So now we need to do the same thing for the V axis. Because we're going to need it later, we'll do this by creating a brand new UVWXForm operator. Then export the fixed tile V value For clarity, rename this operator VXForm and wire the node between the existing UXForm operator and the generator. Select the existing arithmetic and number of tiles on U node and create a copy. Rename the copied numeric node to number of tiles on V and set the value to 13 from the modify panel. This is the number of tiles on the V axis in the texture, so dividing 1 by this value will give us the correct tiling to display a single tile image on the segments. Now wire the copied arithmetic node to the V fixed tile input of the XForm operator. Each segment will now be mapped with a single tile. If you look closely, at the moment this also includes the grout or the joint between the tiles. It's often the case that we want to remove this, and to do that we need to add a couple more controls. Firstly, we need a small adjustment to the tiling so that we can scale it to exclude the joints. And we then need to be able to slightly offset the position to recenter the texture on the segment. To do this for both the XForm nodes, right click and export U or V fixed offset, depending on the operator. Now, add a new numeric node to each of these exported values and change the type to float. Turn on limits and set minimum to -1 and maximum to 1. You can now use these to slightly adjust the position of the map. So now let's adjust the scale. We already have sizes being piped into the tiling inputs, so to change the scale we need to add an adjustment to the existing values. To do this, create 2 new numeric nodes, one for each UVWXForm operator, and rename these UTileAdjust and VTileAdjust. Next, also create 2 new arithmetic operators, one for each UVWXForm, and leave the mode set to add. Wire the existing divide nodes to the first input, and then wire the new numeric nodes to the second input. Finally, wire these arithmetic nodes to the U or the V fixed tile inputs on the UVWXForm operators. You can now adjust these new parameters so that only the tile shows on the segment, clipping off the joints. Now that we've isolated a single tile, we can randomize the offset to select the others in the source texture. To do this, we'll use the UVWXForm's randomize features. This enables you to set a range for the tiling, offset and rotation of the UVWs, and optionally use a step value as a multiplier to return values from within that range. Fortunately, we've already calculated the correct step values by dividing 1 by the number of tiles, so we just need to export some values and hook up the existing arithmetic nodes. Before we do that though, make sure random offset is turned on by going to the UVWXForm operator's properties and activating random offset. Now right click on both UVWXForm operators and export random offset to U and random offset to V, depending on the XForm operator currently selected. Now export random offset step for both UVWXForm operators. Now connect the existing divide node to the random offset step input. Make sure that the correct one is applied, so the U divide is applied to the U XForm and the V divide is applied to the V XForm. And finally, for both UVWXForm nodes, connect the existing 1.0 constant to the random offset 2 inputs. And if you followed this successfully, you'll now have a style that allows you to add a bitmap with tiles or bricks in a stack bond pattern and extract individual textures, with controls to adjust the offset and scale so that you can clip out the grout or mortar. If you want to check it works, you can apply a different material, making sure you adjust the number of tiles on U and the number of tiles on V values to match the new texture. The segment's UVs should be automatically recalculated to match the new bitmap. In the next section, we'll adapt this idea to use a texture that has the tiles in a running bond pattern. To extract individual brick images from a texture with a running bond pattern, we just need to extend this idea a little further by adding different settings to grab the bricks from even rows and different settings to grab the bricks from odd rows. On the screen you can see the texture used in this tutorial. The first row is offset by half a brick, so we're going to need to move the texture coordinates half a step distance along the U-axis to compensate. Because the coordinate change will only work when the bricks are offset, we double the V step value to pick only the odd rows. This means you now have only whole bricks, but we're actually missing the even rows shown here. To get the textures from the even rows, we need to create a separate UVW Xform map that moves the UV coordinates up one brick on the V axis. Because it's still using the same step value as the odd rows, this will also sample 2 rows apart and grab the remaining bricks from all even rows. So let's put this idea into practice. Select the network of nodes we created in the previous example and click the copy button from the top toolbar to add them to the clipboard. Now select Railclone bricks from the scene and open the style editor. From the top toolbar, paste these UVW nodes into the existing Railclone object. As you can see, you can easily reuse groups of nodes just by copying and pasting. Connect this group of nodes between the existing segments and the default input of the generator. And to make this graph a little simpler to read as we add more nodes, roll up the existing arithmetic node by selecting them and clicking Collapse from the top toolbar. This will hide the inputs and make the graph look less busy. Now to match the bitmap, let's change the number of tiles on U value to 4 and the number of tiles on V value to 8. The bricks look better, but because of the running bond, some bricks have a joint in the middle. So to fix this, we need to do 2 things. Select every other row and shift the tiles 1/2 brick to the right. To pick every other row, we need to double the current step value. So to do this, create a new arithmetic node and wire the existing V divide arithmetic node to its first input. Then connect the new arithmetic node to the V Xform operator's random offset step input. So we need to multiply the current V tile value by 2. And to avoid adding more nodes and keep it a bit simpler, let's do this with an expression instead. This can be useful if you want to create arithmetic relationships, but avoid adding too many constant nodes. So click on the arithmetic node we just created and change the mode to expression. Click to open the expression editor and enter input 1 times 2. The input 1 variable calls the value wired to the arithmetic node's first input slot. If more nodes are attached, you could access their values using input 1, input 2, input 3, etc. So now all the samples will have a texture with a joint because we're sampling only the odd rows. So to shift the samples half a brick to the right, add a new UVW Xform operator and wire it between the 2 existing UV Xform operators. Right click on this new Xform operator and export fixed offset U and V. To get half the size of the brick, create another new arithmetic node and set it to expression. Open the expression editor and enter input 1 divided by 2. Wire the U divide node to the input slot 1 and wire the arithmetic node's output to the new UVW Xform operator's exported U fixed offset value. This setup is now correctly extracting the brick textures, but only from the odd rows. Let's grab the textures from the even rows as well. To do this, copy the UVW Xform operator we just created, then wire both these new UVW Xform operators to a new randomize operator, and wire the randomize operator to the V Xform operator's input. So to offset one of these Xform operators to grab the even rows, attach the V divide node to the V fixed offset input. This reintroduces the joints to the center of the bricks, but this is because we also need to disconnect the U offset for this node. When the U offset is removed, the even segments are no longer offset on this axis and they sample the textures correctly. And that completes the setup. This node tree looks confusing at first, but it's a good demonstration of how you can use arithmetic operators to create complex relationships between nodes in Railclone. The good thing about this setup is that you only have to do it once. Now that you've got this node graph, you can copy and paste it into any style where you might want to sample parts from a tiling texture. And because we've exported so many parameters, it's easy to adjust them directly from the modify panel without needing to open the style editor and alter the graph. Using these techniques, you should be able to use the UVW Xform operator to help extract regularly spaced elements from tiling textures and minimize the amount of work you have to do slicing and preparing your maps in Photoshop. Of course, for some uses, you don't need to use step values at all, and you can randomize within the full range of the UV offset and rotation values for each segment to create nearly limitless variation. This is much simpler, often requiring only a single node, and to see how it's done, check out the Railclone 2.4 Features Tour video for an example. Otherwise, stay tuned for future training, or for more information about many aspects of Railclone's features, please see our reference section or visit the tutorials page for more tips and tricks videos and in-depth tutorials.